Okay, here's some homework help for you. So we're factoring this expression. This problem is like notes example number 1, and we're going to use the difference of squares factoring formula. A squared minus b squared equals a plus b times a minus b. So we see here we have sine of theta squared minus 1 squared. You can think of 1 as 1 squared. So that's going to factor into sine of theta plus 1 times sine of theta minus 1. And you can always FOIL this, use the FOIL method to check it and make sure that it works. Number 15, this problem is like notes example number 2. And so again, even though it looks more complicated, it's just an example of a variation of a squared minus b squared, a difference of squares, equals a plus b times a minus b. So our a is sine of x plus 1, and our b is sine of x minus 1. So we're going to have a sine of x plus 1 plus b sine of x minus 1 times a sine of x plus 1 minus b. Now put parentheses around b since you're subtracting it so that you can distribute the minus sign. Okay, now let's simplify. So notice in the first one you have a plus 1 and a minus 1. You can cancel those. And what you have left is sine x plus sine x, so that would be 2 sine x. And in the second one, let's go ahead and distribute the minus sign before we do anything else. So we have sine of x plus 1 minus sine of x plus 1. Minus negative 1 will be plus 1. Okay, so here we have a sine of x and a minus sine of x that can cancel. So all we have left is 1 plus 1. So we have 2 sine of x times 2. And we could write that as 4 sine of x. Okay. Number 17. This one is factoring like a trinomial. You can see notes example number 3 for one like this. And so when we factor a trinomial, we typically just break it down into a product of 2 binomials. So to get 2 sine squared x, one of them would have to be 2 sine x, and the other one would have to be 1 sine x. And then at the end to get 1, you'd have to have 1 times 1. And then in order for it to add up to a positive 3 sine x, you need plus 1 and plus 1. That way the insides multiply to give you 1 sine x, and the outsides multiply to give you 2 sine x, and that adds up to 3 sine x. So here are the factors. Number 19, also like a trinomial, but this one is like a quadratic in disguise because it's not actually squared. It's to the 4th, but that's okay. We can use the same kind of method. So to get cosine to the 4th x, you would multiply cosine squared x and cosine squared x. And to get 1, you would multiply 1 times 1, and then plus and plus, so that in the middle they add up to 2 cosine squared x. And that's it. Oh, you know what? We could write that as cosine squared x plus 1 quantity squared, since we have the same factor twice. That would be good. Let me clean that up a little bit. So you could write it either way. All right, 21. So the notes example showed us a sum of cubes. We saw a cubed plus b cubed. This is showing us a difference of cubes. A cubed minus b cubed. Remember that factoring formula is a minus b times a squared plus ab plus b squared. Remember the SOAP formula? We have the same sign and the opposite sign and the always positive sign. Okay, so what we have here is we have sine of x cubed. So sine of x is our a. And then we have minus cosine of x cubed. So cosine of x is our b. So we start with a minus b, sine of x minus cosine of x. And then we multiply it by a squared, sine squared x, plus ab, sine x, cosine x, plus b squared, which would be cosine squared x. notice that we have sine squared x plus cosine squared x, which is 1. That's a Pythagorean identity. So let's replace that with 1. So we have a factor of sine x minus cosine x, and then we have a factor of 1 plus sine x cosine x. And those are the factors. Okay, 23. This one corresponds to notes example number 6. And we're switching gears now. Instead of factoring, we are simplifying expressions. And we're expecting to end up with a constant or a single function or a power of a single function. Okay, so let's replace tangent theta with sine theta over cosine theta. That's a ratio identity. Sine theta over cosine theta. And then that's being multiplied by cosine theta. So we can cancel the cosine thetas, and all we have left is sine theta, and that is a single function. 25. This one also corresponds to notes example number 6. So we're going to change this to a constant, a single function, or a power of a single function. So let's replace secant r with 1 divided by cosine r. So 1 divided by cosine r times cosine r. Oops. So you can cancel the cosine r's, and all we have left is 1, and that is a constant. Number 27. This one corresponds to notes example number 7. And let's replace tangent beta with sine beta over cosine beta. So we have sine beta, isn't it fun to use all these different Greek letters, times sine beta over cosine beta over cosine beta. Okay? So if we simplify the numerator, it is sine squared beta over cosine beta. And that is over cosine beta. Now, let's think of this as the denominator is a fraction too, cosine beta over 1. That way we have a fraction divided by a fraction, and we can change it to the top fraction multiplied by the reciprocal of the bottom fraction. So multiplied by the reciprocal of the bottom would mean multiplied by 1 over cosine beta. So now what do we have? Now we have sine squared beta over cosine squared beta. Sine over cosine is tangent, so this would be tangent squared beta. Now, maybe this wasn't the most efficient way to do it. Probably if I went back to the beginning, I would have done it differently and gotten it done in fewer steps. But, you know, it's okay. It's not a race. Okay, next one, 29. Again, simplifying to a constant, a single function, or a power of a function. So let's take a look at our Pythagorean identities. Here's the one that has secant squared theta in it. And if we take that and subtract 1 from both sides, we're going to get tangent squared theta equals secant squared theta minus 1. So even with an x in it, same thing. This is going to be equal to tangent squared x. And that is a power of a function. So that's it. Number 31. Let's start by taking sine squared x over cosine squared x and replacing it with tangent squared x using that ratio identity, squaring that ratio identity. And then let's replace cosecant x with 1 over, oops, wrong one, 1 over sine theta. So we have sine x times 1 over sine x. So we can cancel the sine x on the top and the bottom. And now what we have is tangent squared x plus 1. And now we can use a Pythagorean identity. 1 plus tangent squared x, oops, 1 plus tangent squared x is equal to secant squared x. So this is equal to secant squared x. That's a power of a function. And then we have one more. Okay, so cosecant squared x is the reciprocal of sine squared x. Okay, so we could think of it like this. 1 over cosecant x is equal to sine x. So then if we square it, that means we have 1 minus sine squared x. And when we look at this Pythagorean identity down here, if we were to subtract sine squared theta from both sides of it, we would have cosine squared theta equals 1 minus sine squared theta. So that tells us that 1 minus sine squared x is equal to cosine squared x. And that is the power of a function. So that's it. Okay, hope that helps you. Thanks a lot, everybody. Bye-bye.